How does stress cause wear and tear in materials? Imagine a tiny force repeatedly pushing and pulling on a metal part. Over time, that small push can cause big problems. That's because stress in materials is like a hidden enemy that slowly breaks things down. When a material faces stress, it can change in ways that weaken it and cause wear. This process is a common reason why machines, tools, and parts fail eventually. Stress causes wear in several ways. One way is through abrasion and adhesion. When surfaces slide against each other, tiny bits of material can scrape off or stick and transfer from one surface to another. This physically wears down the material over time. Think about a car brake pad rubbing against a disc. The friction slowly wears the pad down. Another way stress causes damage is through fatigue wear. When a material is subjected to repeated cycles of stress, even if each one is below the level that would cause immediate damage, tiny cracks can start forming. These cracks often begin at surface imperfections or grain boundaries inside the material. With each cycle, the cracks grow a little more until pieces break off, creating wear particles. This process is common in airplane wings or engine parts that experience constant stress cycles. Stress can also cause subsurface damage called delamination. When parts are under constant stress, tiny microstructural changes happen beneath the surface. These changes can lead to cracks forming inside the material and eventually layers separating. This kind of failure speeds up wear and can cause parts to break apart more quickly. High localized stresses, like impacts or sudden shocks, can cause rapid damage. These sudden forces create very high stress concentrations in small areas. This can cause microstructural damage or even cause tiny adhesive layers to form, which then break off easily. For example, a hammer hitting a metal surface creates a burst of localized stress that can cause small cracks or surface peeling. On an atomic level, stress can break the bonds holding atoms together. When these bonds break, atoms or molecules can detach from the surface. This atomic level wear is especially important in very hard materials like diamonds. When stress causes bonds to break, tiny particles can come loose, gradually wearing the surface down. Understanding how stress causes wear helps engineers design better materials and systems. They can reduce stress concentrations by shaping parts carefully, applying protective coatings, or choosing materials that resist fatigue. For example, in manufacturing, controlling impact forces during cutting or machining can greatly extend tool life. In the end, stress acts like a slow but persistent force that causes mechanical deformation, crack formation, chemical reactions, and atomic bond breakage. All these processes weaken and degrade materials over time, leading to failure and breakdown in many mechanical systems. Recognizing these mechanisms helps us build more durable products and prevent unexpected failures.